Hi everyone. Right now we're talking about sleep and wakefulness cycle. So let's work our way through. Imagine this person just woke up. What his brain is gonna act like, what his life is gonna be like. Let's just have a look at that. So sleep centers are not activated. Obviously, this person just woke up. Why would his sleep centers be activated? Wouldn't make sense. Reticular activating nuclei release from inhibition. So they're not. So in easy terms, they're not inhibited. So I am just cutting out the term inhibition. So they're not inhibited, right? Reticular activating nuclei are what? They are activated. When they're activated, what will happen? They'll cause wakefulness, right? Excitation of cerebral cortex, they're going to cause excitation of cerebral cortex and the peripheral nervous system. So they're going to cause excitation of CNS as well as PNS. Easy. There'll be positive feedback to the reticular activating nuclei. So there'll be a positive feedback to the same reticular activating nuclei. So again, what happens? This person wakes up. The sleep centers, they are not activated. Reticular activating nuclei, they're going to, whatever inhibition was acting on them, it's removed. So the reticular activating nuclei, they become active. They are going to send impulses to cerebral cortex and peripheral nervous system to excite them. From cerebral cortex, the impulses are going to go back to the reticular activating system or reticular activating nuclei. I call it normally the RAS system. And what happens is that there's positive feedback. So there'll be sustained wakefulness. Fatigue of reticular activating neurons. So as the old theory suggested, as the day goes by, there'll be fatigue of the RAS system, because of which there'll be reduced positive feedback between the reticular nuclei and the cerebral cortex. So basically, decreased or reduced positive feedback. Sleep centers take control, inhibitory signals from the sleep center suppress activity in the reticular activating system. So now that, first of all, there was positive um, signals going from cerebral cortex back to the reticular nuclei, but with the passage of time, the reticular system is going to get fatigued. There'll be reduced positive feedback, because of which what will happen? All those sleep centers that we've already discussed about, these were the sleep neuronal centers, they'll be activated. These do what? Graphene nuclei, they're going to secrete serotonin. Serotonin is going to cause induced sleep. Practice solitarius does what? It inhibits RAS further. What about the rostral? Oh god, this is the glitch that I hate the most. Anyways, so the rostral suprachiasmatic system, it's associated with the circadian rhythm. What is it going to do? It's going to release GABA. What does GABA do? GABA inhibits the neurons and it's going to cause this sleep. So GABA is going to cause sleep. Then after that, because it has an inhibitory effect, after that we have the diffuse nuclei in thalamus. They're going to suppress the um, they're going to suppress the sensory stimulus, right? So yeah, so these are the sleep centers that will be stimulated. Sleep centers take control, inhibitory signals from sleep centers suppress activity in the RAS system, and they're going to transition to sleep. And in sleep, what will happen? Restorative functions will take place during sleep. Metabolic waste is cleared, and energy reserves are replenished. Sleep cycles occur, preparing the brain for next wakeful phase. Reduction in sleep center activity. Sleep centers reduce inhibitory output as restorative needs are met. So during sleep, all of these things will happen. All the restorative effects will take place. But as the person is completely ready for the next cycle of wakefulness, what will happen? That the restorative there'll be reduction in sleep center activity. Sleep centers are going to reduce the inhibitory output and the circadian rhythm and external stimuli are going to signal the RAS to resume its activity, and a person will again be active once again. So reticular activating nuclei are deactivated, excitation of cerebral cortex in peripheral nervous system, transition to wakefulness. This is very simple. Let me explain this to you in simpler terms as well. So for that, I'll have to find a white page. Okay, I think this much is enough. First thing first, what happens? A person just woke up. Once a person is awake, the RAS is inhibited. The RAS is activated. Its inhibition is released. So it's relieved of its inhibition, and RAS is activated. Reticular activating system is activated. A person will be awake now. Now, RAS does what? It sends signals to the cerebral cortex. Not just cerebral cortex, but also the peripheral nervous system, and it will signal both of these to, be active and perform the functions. Cerebral cortex sees, oh, I'm getting signals from RAS. It's going to send signals again back to RAS to further activate it. So RAS positive signals go back to RAS, and RAS is further going to activate the cerebral cortex. This is going to do what? This is going to cause sustained wakefulness, so that a person doesn't just sleep after one bout of wakefulness. No, he has to remain awake for the entire day. So there'll be sustained wakefulness. Now, after, let's say, a big chunk of the day has passed, RAS has become fatigued. Obviously, RAS has tired down now. Now, what will happen because of RAS getting fatigued? The person's sleep centers will get activated. What were the sleep centers? So you had the rostral hypothalamic or suprachiasmal area, which released GABA. GABA was an inhibitory neurotransmitter. Other than that, we had very important serotonin being released by the raphe nucleus. Other than that, we had very important uh, the diffuse thalamic nuclei, which was suppressing the sensory stimulus. Other than that, we also had very important uh, reticular activating system. There was another thing which was called, what was it called? Let me just recall. Yes, nucleus of Trachea solitarius. This was doing what? This was inhibiting the RAS system. So all of these sleep factors, they'll get activated, and they're going to do what? They're going to cause further sleep, right? They're going to further cause the sleep. And once a person has slept, all the restorative functions will start taking place. The metabolic rate, all of that, the waste will be removed, and all the restorative effects will be completed, and there'll be cycles of REM and non-REM sleep. Once that all is completed, a person's RAS will again be stimulated, and also not just that, but also circadian rhythm is going to stimulate, and the sensory stimuli from the surrounding. For example, in the morning, if there's a rooster that's, you know, just what is that sound of rooster called, whatsoever. So a rooster starts uh, giving its morning prayers, and then the people that are, making noise as soon as it's morning. You can hear a lot of transportation outside and all of that. So the sensory stimulus from the environment also causes a person to wake up, and this is basically the entire cycle. Easy. So a person just transitions to, and then again RAS will be activated, reactivated, and there will be excitation of cerebral cortex and peripheral nervous system, and again there will be transition to wakefulness. Now, what are the functions of sleep? Very important. This is super important. It restores the natural balance among the neuronal centers. It restores normal levels of brain activity, balances different functions of the central nervous system. It's going to restore natural balances among the neuronal centers. It's going to cause cognitive and emotional regulation. It's going to facilitate learning and memory consolidation, because memory consolidation happens in REM sleep. Other than that, if for neural development and maturation, so it also causes the growth and maturation of neural networks, especially in young children. Synaptic optimization, it prevents, it basically erases unnecessary synapses to prevent decluttering in the synaptic network. And it also causes performance optimization, not just synaptic optimization, also performance optimization, because it prevents degradation of cognitive and physical performance. It improves overall productivity and health. So what does it cause? First of all, it causes cognitive and emotional regulation. It causes neural development and maturation. It causes synaptic optimization. It causes performance optimization. Performance and synaptic optimization, then neural development and maturation, cognitive and emotional regulation. If these 4 points you remember, it's more than enough. Other than that, you can also say, obviously, it helps with the memory consolidation, it helps with metabolic and energy conservation, and immune function, and sport and homeostasis is done during sleep. The functions, these are very easy to memorize. So that's pretty much it. We are completely done with the sleep. And if there's anything else that needs to be covered, let me know. We'll cover that as well. In the next video, let's just look at the difference between seizures and epilepsy.